What's going on, everyone? You're back with Jono for another quick math lesson. Today we're going to look at reading and constructing Venn diagrams. This is going to be one of the easiest things you do in maths for a very long time. So a Venn diagram is just a visual representation of some data that's been collected, usually in a survey. The most important thing that we need to know when we're talking about these Venn diagrams is that we're usually looking at data that is not mutually exclusive. So mutually exclusive means that you could not get both options even if you tried. So for an example, if you're playing cards and I said, pick a card, it couldn't be a mix between red or black. The next card you're going to pick is either red or it is black. There's no in between. So these two things are mutually exclusive. But Venn diagrams are looking for things that are not mutually exclusive, so where we can have both outcomes represented. So if you've got something that is mutually exclusive, right, like in that card example, we just draw two circles that do not overlap. So in this one, it would be you're either drawing a red card or you are drawing a black card, and there's no in between. So when we get to a Venn diagram, they look like this, and they're really intuitive to read. So for this example, we've got people that like basketball and people that like footy. And we want to see, hey, what's the probability of finding someone out of the people we surveyed, and what sport do they get into? So straight away, we can see that the middle bit is really important. This is the intersection of both of these things. These are people that like basketball and like footy, and there are 8 of those out of the people that we talked about. The other one that's really important is outside of these circles are people that said, you know what, I actually don't like either. It's not my thing. Both of these represent people that obviously exist, and we have to make sure we account for them in our Venn diagram. So the first thing that I want you to do anytime you get one of these questions, even if the question doesn't specifically ask for it, is work out how many people did we ask in this survey. All you've got to do for that is add these numbers up. So for this one, we've got 14 plus 8 plus 18 plus 6 is equal to 46. And once we've done that, all the probability questions are going to become much easier. The next question here is how many people like basketball? And this is where I really want you to slow down. The maths for these questions is really, really easy, but reading the question is the most important thing. So for people that like basketball, that's anyone in that basketball circle. So we've clearly got those 14 people, but also the people that like basketball and footy still count. They still like basketball. So instead of saying, there's just 14 people, we've actually got 22. Now this would change if the question was slightly different. If the question said how many people only like basketball, then we would be talking about those 14 people. But because it says basketball total, we need to include the only basketball fans and the people that enjoy both. And so the questions you might see from there is, hey, if I just pick someone at random from this survey, what's the probability that they like footy? All you've got to do here is add up everyone in the footy circle, okay? It's not only footy, it's footy. So we just have to do 18 plus 8, which is equal to 26, divided by 46. We've obviously got to simplify our fraction, so our answer is 13 divided by 23, and we're done. So these questions are not difficult. Reading these Venn diagrams is actually pretty easy, but making sure that we take the time to get the question correct, knowing what we're actually looking for, is the most important skill here. So sometimes we get asked questions in a Venn diagram that have these strange symbols. So one looks like a U and one looks like an N. We do have to make sure when we write these, we are really clear that they're not U or N. So just doing them quite big and bold will help you out. So the U stands for union. And this is just anything that's in one of the circles. So the way to kind of think about it is for this union, it's anyone that you surveyed that kind of likes either of the options you gave them. So they're in unison, enjoying something. So that's the way that I remember it. It's just something that is in the circle, and that's all we need to know. So the only people we need to ignore are the ones that said, I don't like either of these things, or the ones that are outside the circle, but still in the sample space. Now the N, the upside N, is called the intersection. And this is where we've got people that only like both, that middle section. The way that I remember it is that the N, you could say, instead of intersection, you could say intersection, right? Starting with the N, and it's only those people in the middle that count for these questions. So the question could look something like this. I've just got A and B here to represent two categories, and you could get a question that looks kind of like gibberish. We've got the probability of A, U, B. So what this question's asking for is, what is the probability that I pick someone from this survey that likes A or B or both? They just have to like something. So all I've got to do is add up the numbers inside the circle. So I've got 17 plus 13 plus 15, which is equal to 45. And because I need a probability, I've got to divide it by all the people that were surveyed. So that's those 45 people plus the 5 outside. So my answer is 45 over 50, which simplifies to 9 over 10. And that's all we've got to do. So even though the question looks like gibberish, just knowing that it's, hey, how many people are in the circles is all you need to know. This next question is using the intersection. So this is the probability that I find someone that's A and B, or in the intersection. And that's only the people in the middle. For this one, it's just those 13 people divided by the entire sample space, which is 50. 13 over 50 doesn't simplify, so that's our answer. So just making sure we're on top of the U and the N is really important. The only other type of questions you could get look like this. This is asking, hey, what's the probability that we get the complement to A, or really not A? That's the important part here. So for this includes the people in the middle, because they would say, oh yeah, I actually do like A. So we're only talking about these two that are on the opposite side or outside that A circle. So for this, there's 20 people divided by the 50 asked, meaning that we get the answer 2 over 5. And then again, the probability of not B is just those 17 people that are in the A camp, plus the 5 people that don't like either, which is equal to 22 over 50, meaning that my final answer is 11 over 25, and that's my final answer. So this stuff is not too difficult. Again, it's just reading and knowing what the question wants from you, and that's the important part. The other skill that we need to know is we've got to be able to draw a Venn diagram from the information that's given. So in this example, we've got 40 people surveyed. 16 of them love milk, 22 love juice, and then we've got 8 people that aren't into either. One thing that you might notice immediately is, 22 plus 8 is 30, plus those 16 is 46, but only 40 people were surveyed. So we're actually run into an issue immediately. We've got more kind of responses than the people we surveyed. And that's because there are people in this survey that said they like both milk and juice, and we need to account for them. So the pro tip that I use for these ones is immediately add up the responses given, not the surveyors. So we have that 8 plus 22 plus 16, we've got 46 straight away. Then you've got to minus the number of people surveyed immediately from that number. And then we put the answer to that in the middle and work from there. Once we've done that, the rest of it makes a lot of sense. We had 16 people that like milk. I've already accounted for 6 of them in the middle, so that means 10 must be over there. For the 22 people that like juice, again, I've already accounted for 6 of them, so that means that there's 16 people left over that only like juice. And then the guys that aren't into either, we just put them down there. We don't need to account for them at all. There's just 8 left over. The best thing about this is you can always check your answer. As long as these numbers add up to the people surveyed, so in this example, 40, we know we got it right. So 10 plus 6 plus 16 plus 8 is equal to 40. Happy days, we got this one correct. So I know that this is a little bit of information to come at you straight away, but I guarantee you the maths is not too hard. The difficult bit is just reading the questions correctly and going slow enough to realize when they're trying to kind of trick you. I do hope you found this lesson helpful, and I'll see you later.